Let's try to generalize the problem that Gauss solved. Suppose you're asked to add up the first n natural numbers. Pause this video and take some inspiration from Gauss and try to compute this sum. So, like we did before, we are going to rewrite this series in descending order. We are given these numbers in ascending order. Let's rewrite them in descending order. So, we write n first, followed by n minus 1, n minus 2, and so on. Finally, we get 3, 2, and 1. So notice that these numbers again get aligned in pairs, where each pair of numbers adds up to n plus 1. So when we add these two equations up, we get 2s is n plus 1 plus n plus 1 plus n plus 1 as many number of times as the number of terms in the series. The number of terms in this series is n. So this would come to a total of n times n plus 1. This means s can be written as n times n plus 1 divided by 2. So if n is 100, then s would be 100 times 101 divided by 2, which is 5050. And that was the specific problem that was given to Gauss. But now we have a general solution. We can add up the first n numbers for any value of n. Now we could have obtained this same sum by pairing up the numbers in the same line, like we did before, like we saw how Gauss did. So let's just try to do that as well. S is this particular sum, and let's pair up 1 with n, 2 with n minus 1, 3 with n minus 2, and so on. How many such pairs would we form? Well, we need to distinguish between two cases here. If n is even, then it's pretty easy to see that there would be n by 2 pairs of numbers, each pair adding up to n plus 1. So 1 plus n is n plus 1, 2 plus n minus 1 is n plus 1. So all pairs are adding up to n plus 1, and there are exactly n by 2 such pairs. So the total sum S would be the number of pairs multiplied by the sum of the numbers in each pair. And this answer, n times n plus 1 divided by 2, is basically what we got using the slightly different method that we used a few minutes ago. But what if n is odd? If n is odd, then we won't be able to pair up all the numbers, because there would be a number in the middle which won't belong to any pair. The other n minus 1 numbers, apart from this middle number, the other n minus 1 numbers can be paired up, because if n is odd, then n minus 1 would be even. So the remaining n minus 1 numbers can be grouped up into n minus 1 divided by 2 pairs, each pair adding up to n plus 1. So the value of S would be the number of such pairs, which is n minus 1 divided by 2, times n plus 1, plus the value of this middle element plus this middle number. Now what is this middle number? Well, we know that there are n minus 1 divided by 2 such pairs, and the values of the number here on the left hand side are 1, 2, 3 and so on. So the value just before the middle element, would be n minus 1 divided by 2, because that's the number of pairs we have, and the left endpoint of each pair is basically that number itself. So the first pair has a left endpoint 1, the second pair has a left endpoint 2, and so the n minus 1 divided by 2th pair would have a left endpoint of n minus 1 divided by 2. This means the value of the middle number would be 1 more than this value. So the middle number here would be n minus 1 divided by 2 plus 1, and that would be n minus 1 plus 2 divided by 2, and that's n plus 1 divided by 2. So we can compute what s is. S would be n minus 1 multiplied by n plus 1, that's n square minus 1 divided by 2, plus the middle number, which is n plus 1 divided by 2. So the this 1 here cancels out with this 1, and so we get n square plus n divided by 2, which is n times n plus 1 divided by 2. Again, we got the same answer as before when n was even, but through a slightly more complicated calculation. So this was a slightly longer way of proving the same, of getting the same answer as before, and this was longer because we had to divide the problem into two cases, the case when n is even and the case where n is odd. But if you follow this particular approach, it doesn't matter whether n is even or odd, it applies regardless of whether n is even or odd. So the answer is n times n plus 1 divided by 2 in both cases. So let's get back to our original problem. The original problem was to compute the sum of the first 25 natural numbers. So now that we have a general solution here, we can just substitute n is equal to 25 in this formula. So s would be 25 times 25 plus 1 divided by 2, which is 25 times 26 divided by 2, which is 25 multiplied by 13, which turns out to be 325. So that's the value of the sum of the first 25 natural numbers. This is 325.